Okay, so in our first example, we will be looking at the plugin Lunchbox, right? So you can see here, I guess on our Food for Rhino website, it will give you a quick kind of description about what it is and how to install it, right? As I mentioned before, some components you just download a GHA component and you put it in the correct folder, and after you unblocked it, and that's fine. In the case of Lunchbox, you can see it uses an installer, right, as the way to install it. So just be aware that once you've completed your download, you will run the installer and you'll probably have to restart your, I think it's just restart Rhino. It should be fine. But you can see here that there is more recent update version 2, right? Which, really just came out recently. So you might as well pick that one up if you're using Rhino 7 for Windows or later, right? And so you can see it, gives you a lot of additional functionality, right? So again, I mentioned that Lunchbox was very popular early on, when a lot of parametric design was about working and developing facades and stuff like that, right? So you can see, and doing things with the tractors and whatnot. So you can see that it has, lots of different kind of subdivision tools, right? Paneling tools. It has structural design aspects, right? It has some, kind of previously difficult to generate surfaces and objects, right? And that are all, kind of available with the click of a button, basically, right? And again, things like flatness check, etc., right? Those are all things that are very useful in the kind of facade design realm, right? So you can see some of the experiments that people did with it, right? These are still pretty early examples, but functionality is quite good, and it does actually make a lot of tasks really a lot easier, right? So, okay, once you've downloaded that, you can get right into looking at how to work with it, right? So, let's see here. Good. Um, so we're going to assume that you already have, okay, well, first of all, after you install it again, you will get a new tab, right, called the Lunchbox tab, and all those components, right, will be available here, right? This whole set of machine learning stuff that was just recently released, I think, with this latest edition of Lunchbox. So I have not tried those at all. They were, I guess, just came out last month, actually. So that would be interesting to look at. But again, math functions for objects and surfaces, panels, structure, etc., right? So we're going to assume that we have a surface already. Of course, you can develop a surface any way you like inside Grasshopper. For this example, since we do have a number of things to get through today, I'm just going to quickly make a surface in a Rhino. Then I'm going to change the degree to 3. Right. Turn on the curves and do a little bit of modification. And again, you don't have to be precise or anything with this. This is just purely for the sake of, running an example. Okay, so let's say that's the surface that I'm interested in. So it looks kind of like this, right? Okay. All right. So we're going to bring that into our workspace. It's a plane, that's a surface. And hide the original. Okay. In Lunchbox, let's look quickly at what some of these components will do for us, right? So here you can see that we have lots of choices. Let's say, it's often common actually that when we're defining geometry in architecture, let's say a roof or something like that, we might just define it with some surfaces, right? But at the end of the day, when we're talking about building and assembling, the roof is never going to be just one piece like that, right? It's always going to be subdivided into panels to be moved into place and fixed in space, right? So these panels, right, are very useful for just that reason, right? Because we can, for instance, take, say, let's do, for instance, triangular pattern A, right? We can put our surface into it, right? And then if I hide that, you can see that it automatically kind of rationalizes that geometry, right? So what I mean by rationalizing is that it's flattened, it's preserved the kind of overall appearance, right, of and shape of the roof, but it's flattened out. It's flattened out all of that geometry, right? So now we don't have to deal with any curvature in our surface. And we have into modifying the subdivision, right? So depending on how refined and how big the panels are that we're thinking about, we can do that any number of ways, and that is really convenient for us, right? It offers this functionality pretty much for all, well, not a whole lot, but many different variations of paneling, right? And, certain paneling will allow you to create different kinds of effects, right, in your design. These are useful not only, I think, for, doing facades and roofs, but also things like tiling and floors, right? If you're interested in doing, more kind of interior stuff. Oops, selected the wrong one. Right. So again, it's not, I don't think it's, it's super exciting in terms of what it allows you to, the stuff that allows you to generate, but it's very useful as a kind of architectural tool, right? To make things look more realistic. And in fact, it's, solving a lot of problems for us in terms of transitioning from kind of digital project to built, built project by helping us to rationalize geometries that, are typically very difficult to actually build and manufacture, right? So again, these ones, I mean, you can play around with all different types that you're interested in. Maybe I'm just going to pick this one for the rest of this example. Right. So we can also add to that things like structure, right? So if we go from our panels to our structure tab, you can see we have lots of different choices, right? So let's say we take this one, you can see that now I have an easy way to kind of make a matching structural grid, right, that fits right onto our kind of triangulated pattern as well, right? They have, this one is probably even more similar, right? Because it includes kind of cross bracing as well as the kind of square grid. And I think even more interesting is something like some of these space trusses, right? Let's do truss 1 first. And then we need another slider to define the depth, right? So if we unhide this now, you can see that that's actually quite a fast and easy way to describe a truss system for basically any kind of surface geometry that you have, right? And, you know, of course, the great thing is that if you want to modify it at any point, you can still come in here and, you know, tweak the geometry a little bit, and everything kind of updates in real time, right, to resolve that shape. So you can slowly kind of modify the geometry to whatever it is that you're actually aiming for, right? And that it will continue to update and solve for you all the different kind of subdivision, right, of the paneling or resolution of the kind of structural elements and stuff like that. Now, it's not doing any kind of real calculation for you in terms of what the loading is, right, or the size of the elements, right? You still have to, you know, kind of decide that for yourself, right? But, you know, it's already at least going to be able to help you visually kind of resolve what the look will be, right? And once you've, you know, had a chance to show maybe your consultant or engineer what it is you're hoping to do, right, then they can start to, you know, look at your model file and discuss with you, you know, the sizing of the members and the depth of the beam and stuff like that, right? So again, this is still very much geared towards architectural practice and not so much for engineering and stuff. But, you know, so look how convenient it is to be able to kind of develop, you know, a pattern with base frame that matches with the pattern of your facade, right? So that you don't have, you know, different grids running into each other and creating a mess, basically, right? So again, very, very useful for, you know, rationalizing geometry and whatnot, right? The only thing is that, well, in this example, we have, you know, we're only working with lines and a flat surface right now. So if we wanted to give that, you know, a little bit more a sense of, I guess, realism, you can see, take the outputs that they give you, right? And then you can start to define the geometry as solid objects, right? Let's reduce this slightly before I go into more detail, just because I don't want to, you know, have really heavy load right away while we're working on it. Okay, so we can go back to, let's say, some of our regular tools. Surface, we have our sub-D tool, the multi-pipe, which is probably pretty useful for doing things like this. We can take, for instance, primary lines, and you can see that the multi-pipe took all of our line segments and joined them together, right? And you can see there's a primary line grid, two primary line grids, right? One on the top and one on the bottom, right? There's webbing in between, right? And then structure on those, I think those are mostly just to identify those points in space. So in this case, we can say, okay, I want to use a certain size, right? For these components, right? And I can just maybe, let's use maybe later. And you can see now I can adjust the size of that framing, right? And if I wanted to have, you know, different sizing for the webbing, I could do that too, right? Just shrink it down a little bit, right? To create a more interesting result. And, you know, that takes care of, for instance, the kind of piping part of it. But what about these panels then? Well, there are a number of things we can do with these panels. We right now, all it's done is kind of rationalize that surface, right? To be, you know, flat components instead of double curved geometry. But let's say we used it to create some openings inside our windows, right? Or inside our roof, right? So for instance, each of these subdivided panels, they may, you know, actually be sunlight, can be opened to allow sunlight into our system, right? So if we use our panel frame component, you can see that now each of those flattened triangles, right, are kind of framed into a frame and a panel, right? The panel is the middle part and the frame is the outer part, right? And we have a scaling factor. So if I use slider for that as well, you can see that now I can adjust the size of the frame and the panel together, right? And again, you know, the frame, you know, matches up with our structural elements very well. So at no point does, you know, it seem like they're kind of fighting against each other. And since it's very nicely kind of split into two lists here, right, you can imagine that, well, okay, so I can make the panel itself, you know, a thin panel, right, that's maybe represents glass in a skylight situation, and then the panel frames, right, can be extruded with some thickness to it, right? So let's go to our surface, extrude. Take the panel as the geometry, the direction, vector, just use Z, and by a certain amount, right? And so slider for that as well. And you can see I can adjust the amount and the thickness of what I think, you know, that edge should be, right? Now, using our kind of traditional parametric design techniques, right, we can, for instance, vary, right, the size of those panels, right? Since again, we can see here they've given us a scale factor for that, right? And right now we have it kind of a constant scale factor for everything, but we could have that, we could set up a kind of relationship between, for instance, the edge boundary and the inner center of our surface, right? So to do that, again, we can find, say, a point of reference, right, from our geometry. So we'll go to surface area, take the panels, and we'll use the center of the panel as one reference, right? And then we'll use the kind of boundaries from our original surface as the second point of reference, right? So we'll find this one here. We'll use our surface edges, right? So you can see the edges here are appearing in green, right? But in order to do that evaluation, we need to find which edge, right, that we want to do the evaluation for, right, for each respective point. So let's do an analysis of the distance, right, from closest point, right? So we have our point and we have our curves. Is that right? Hold on, let me check quickly. So, okay. So here we have, again, data mismatch. Here we have 4, right? And so at the 4th, everything else is getting clustered. So I want to join these all together first into a single curve before I do that analysis. So make it curve 4 here. And there you can see a better distribution, right? So some are matching to this edge, some are matching to there and there and there, right? Okay. So now that we know what point that we're going to do the evaluation to, right, then we should be able to use that as our scaling factor, right, which again is, kind of up here at the moment. Maybe we got to move this off to the end here, keep this together. This is the one that's going to be, kind of variable for us now. And so, again, we could take the distance directly because it's available to us here, right? And use the distance as our scaling factor, or more likely than not, we can either remap or use our math component to use a reduction factor for our scale, right? So, yeah. So you can see here, kind of working because we have smaller panel openings on the edge and bigger ones towards the middle. I don't really love using this because I think there are some of the, the differences are too large. So what we can do is we can use our favorite remapping tool. Where's our min-max component? Here we go. So we'll take our numbers to the min-max, set that as our source, our target between 0 and 1. That's fine. The actual values. And then use this again as our, scaling factor. But something happened. outside the bounds. What if we use this here? Or we need to set this to a 0.1. There we go. So there needs to be, yeah, because 0 just, was running into a problem. So maybe actually it would work better if I delete this and then use this to adjust, fine tune that range of openings, right? So if, for instance, we wanted to be smaller at the edge, right? We can use our domain start to define our, let's say, smallest opening. And we can use domain end to fine tune and decide what we would like for our biggest opening, right? So maybe that looks all right. Okay. So you can see we have now pretty much our entire system set up, right? And let's see what happens now if I tweak these again to make them, make the pattern more dense. Hopefully it doesn't get too heavy. And I think it looks pretty good, right? I think maybe we could go make this range a little bit bigger, so a little smaller at the edges. A little bigger on the middle. That looks not bad, right? Okay, so let's see what that looks like. Oh, that structure looks way too thick though. So where can I adjust that? Not too thick, but too deep. So it's 7 now. Let's say 3. That looks more reasonable, right? So we'll bake these guys out. Bake group, yes. Normal group, yes. And then bake group, yes, okay. And then lastly, well, the panels we haven't done anything with it yet. Just leave them as openings. Or we can actually, yeah, let's just leave them as openings. If you wanted, you could take this panel, right? It's an untrimmed surface, and you could, you could bring it out and make it glass or something like that. Up to you. I don't think I will bake it out at this point because I think it's easier. It'll be easier for us to see the result when it's not there. That looks okay, right? That's our geometry. I do rendered look. You can see that now it's looking like this, but I want this to be offset just a little bit. So let's do this. Oh, too much. That. So, oh, how come? Oh, I didn't bake this out, did I? Bake group, yes. Okay, there we go. That looks better, right? So you can see that, fairly quickly without needing to spend too much effort, we have already generated, fairly reasonable and believable roof structure, right? All of these elements, again, these panels are all flat now, right? We can extract data if we wanted to for fabrication, right? On the size of each panel. We can look at, we're able to control the variation in the scale of the pattern, right? So that we have, smaller openings along the edges and bigger openings towards the middle. We have variable thickness in our space frame and trusses that are adjustable as well. And all of those are, again, if you imagine having to do this manually, probably would be quite time consuming, but we're able to, using some of these simple functions in the Lunchbox tool set, achieve this result quite quickly and easily, right? I don't think I'm gonna talk about everything, right? I mean, I think, some of these things like the different surfaces and, different geometries, they're just purely there because those were things that were, not easy to model necessarily using Grasshopper prior to having Lunchbox. So, I think most people who will come to use Lunchbox will use it basically in this way for this reason, right? Okay, so this is the first example of, playing around with a plugin to Grasshopper, made specifically, I think, for, architects and architectural practice, right? So try this out on your own. See how you like Lunchbox toolset, and we'll come back and look at some other examples next. Okay, so in our next example, we're going to be looking at the plugin Parakeet. Right, so let's go and find that here. Stuck on this Lunchbox thing. Okay. So Parakeet is something for people who like to develop patterns, right? And it's one of those things that I think a lot of, when we were working previously, again, you probably noticed that, those grids are very useful in combination with some different shapes and whatnot to develop all sorts of patterns. So I think in parametric design, there's, some, people who are focused primarily on just developing all different kinds of patterns for application, all different types of design applications, really. And so you can see actually how useful it can be to be able to generate, so many patterns using, just a few components, right? Well, I shouldn't say that there are a lot of components in this set, but they're very straightforward and easy to use, and they can add quite a lot of interest into your design projects, right? So we're going to work with the same surface that we set up in our first example, and we'll just play around a little bit with some of these Parakeet components, right? Again, there are some random things in here, like some primitive and surface generating stuff, right? Again, just like in Lunchbox, they have, some of the more typical kind of mathematical surfaces that, people, like to play around with, right? But are not easy to kind of generate on their own, right? So, you can find them here, you can use it here, or you can use it in Parakeet. Either way, they're okay, right? I think, I would prefer when people created these plugins that, they would kind of focus on what the plugin is supposed to do instead of just kind of like releasing stuff with a bunch of other additional utilities as well, right? Because because now suddenly we have duplicates functionality all over the place in these plugins that don't seem really that necessary, right? So just be aware of that. There's nothing in particularly different or better about these ones than they are, in Lunchbox. You can use either of them to whatever, application you want. The main focus, I think, is really these ones on like pattern generation, right, and tiling, right. So if we look at the tiling first, because it's really straightforward, like most of these are things that you will find in architecture all the time. So let's say brick type H, right? You can put in any surface that you want and apply a brick pattern to it, right? You can change some of the values to adjust scaling and whatnot, right? It's pretty much point and click go, right? I don't think there's anything particularly exciting again about what's happening here, right? But they're they may be useful in some applications, right? Oops, this is on a plane only, so not on a surface, right? Unfortunately, so you can see it just develops down here on its own, and you can, modify some of the characteristics for those, right? Again, the stuff in the tiling here, is very kind of cut and dry and very kind of pragmatic tools, right? The stuff here under the panel generation, I think that's where the Parakeet component gets a little bit more interesting, because they're not really kind of fixed solutions, rather they're strategies, right, to kind of generate your own kind of design solutions, right? And I think that makes it a lot more interesting for those of us who are interested in doing kind of original pattern work, right? Oh, I want to show you one thing while we're still working with this surface, is that there are some components here, like for instance this knit component under pattern generation, that you can actually come in and kind of, you can see there's some wavy lines that are being generated there, right? And it looks kind of weird the way it is now. If we go back to our surface sub D and we use again our curves here, we can go ahead and add some thickness, and then you may be able to start to tell that in fact what's happening is that it's weaving those lines, right? Just modify like this, right? So you can see that it's kind of weaving in between. That's 10 is probably not enough. And depending on the density in the U and V direction, right, that weave will look different. Right? So, you can develop that surface however you want, right? And then based on that surface's geometry, you can actually, create kind of weaved patterns on it as well, right? But that's kind of not the main point. The main point are, again, these ones that allow you to do more kind of generative experiments, right, in terms of developing patterns, unique patterns, I guess, things that aren't just kind of copy and paste it, right? And so let's see if I just picked, you can pick any of those. I think they work more or less the same in all cases. And you can see that it asks for a base polyline set, right? What those are essentially is, when we're talking about pattern making, is our, kind of starting grid, right? So you can try any of those. I'm going to use the hexagon for my example. And I'm going to use those. But okay. Grid cells. Choose here. Okay. Add a slider, control the factor. I'm just going to use this. Okay. So you can see in this way, you're basically can start to modify the appearance of that pattern, right? So, you know, at a certain point that starts to not, you start to not read the hexagon as strongly anymore. Whereas here, the triangle, it becomes triangular, then something completely different. Can also work with more complicated, slightly more complicated ones. And again, when you combine them, they also have an interesting effect as well. Not sure exactly how the rotation factor works, but let's just give it a try. So you can see it's quite interesting. See all the different possibilities that are presented by being able to just work with a few kind of generative components, right? And then overlapping them together to create new and original patterns, right? Okay, so once you've done that and you're at a point where you say, you know, I'm kind of happy with the pattern that I have. I think I don't like this one that much. I do like this pattern. Maybe something like that, right? So once you have the pattern that you like, of course, then we can use our mapping component to map this onto virtually any surface that we wanted to, right? So let's say we have our surface utility. Under utility or transform intersect. Forgot where it was. Map to surface. Where is it? Oh. Well, sorry, I don't remember where this component lies in the toolbar, but if you double click and just hit map, you'll find map to surface, right? And what that will do is, you know, it works the same as like apply UV curves, right? So if you remember from our Rhino class, right, you're able to apply any set of curves that you created within a kind of rectangular box, basically, right? And that would fall on top of any surfaces that you want it to, right? So let's say here we have a source surface, right? And so we're going to use, let's just use the one that we had. Oh no, sorry, our target surface. Our source surface is basically a surface that we're going to generate from this box, right? So let's go ahead and say, sorry, generate that surface that we're going to generate from this grid. So let's go ahead and use our, what is the best way to do that? If we want it to fit precisely, I guess we could use our bounding box. Put all the cells in there. Right now they're doing it individually, so let's do a union box, right? So now we have kind of the result of that. It says we have one flat box. And I think that looks okay. So let's take our flat box and use that as our source surface. And you can see that our source surface got projected onto our, the surface that we had kind of drawn before, right? However, again, because we have so many tiling issues here, one surface and union box created one value here, and we have 2400 UV subdivision 10. Okay, so the reason that we're getting this tiling pattern is probably because those are at default. U and V subdivisions are set to 10. So I'm going to go ahead and change that to 1. And that looks better, right? So now our pattern falls onto our surface, right? Just the way we liked it or expected it to. Now, in a way, this is not so ideal. Well, depending on what you're trying to do, right? But you can see that on the edges here, we have, kind of blank areas, right? Because with the hexagon pattern, we just don't have, a full four-sided sheet, right, that we can project onto. But I guess if we scale down our reference surface, we may be able to get it to stretch out onto that surface directly. So let's take this box and do a scaling. And we just do scale, let's say here. And we pick a factor, the number slider. Center should be the center of our box. So let's do an area evaluation for that. And as we move it out, you can see, let's say we scale it all the way to here. And if we were going to use this now as our source surface, now that's better, right? So you can see that that geometry now doesn't have those kind of empty blotches on the edge, and it fills it all the way, right? And if we wanted to make some adjustments here, we can still, adjust the scaling of the pattern directly onto our surface to whatever it is that we like, right? So again, I mean, really, once we've done that, we could do anything we wanted with that pattern, right? Because it's essentially just a set of curves, right? So if we wanted, we could again give it, thicknesses. Hope it doesn't crash. Okay, that wasn't great. sure exactly. Maybe just because the scale of something is wrong. Hoping that it's because things are too large. Okay, let's not use this one. Let's use classic pipe. Slider. .05. So now you can see you can start to do some very intricate kind of details, right? If we wanted to, I mean, we could even put this like on top. Although, yeah, it doesn't work because we have two different grids now. But, you know, you can see how in this way you could actually start to do some really interesting patterns on your facades or on your landscapes or whatnot, right? And, you know, I think really the unique thing about working with Parakeet is that it doesn't just give you only, you know, all sorts of kind of default tilings. And I think that's common. One of the common complaints about Lunchbox is that, well, you know, after a while, these are your only choices, right? You're not able to kind of develop anything more complex than that with these tool sets because all it does is give you choices. Whereas Parakeet, because it has these kind of pattern generation tools, right, it gives you a lot of freedom to kind of play, explore, and develop your own patterns, right? So I think, you know, for anyone who's interested in developing pattern generation in their designs and stuff like that, well, I think that's a really, you know, useful tool for that. Okay, so Parakeet essentially is used in this way to generate new and different patterns than what you're able to find on your own. So, you know, you don't, you know, you're not relying on kind of some standardized or default patterns, but you have the ability to, you know, become a pattern designer yourself to create, you know, unique effects on your project work, right? So quite a good tool, I would say. Yeah. Okay, so with our last plugin that we're going to cover is one called Pufferfish. And this plugin, again, like I mentioned, a lot of times what inspired people to make these plugins is actually because in the transition from Rhino to Grasshopper, a lot of the functionality that people really liked about Rhino was kind of not carried over directly into the Grasshopper parametric modeling tool, right? And so in Pufferfish, what they're trying to recover is basically the tools that allow for blending and morphing and creating tweens, right? So if we look at some of the examples here, you'll see that these geometries are basically, you know, examples of what people would have, you know, been able to do in Rhino fairly easily, but later on in Grasshopper required considerable effort, right? And so, you know, essentially the idea of a tween, right, is to kind of find the iterations between types of geometry, right? So for example, right, if we did a tween of these two geometries, right, in Rhino, what it would have given us is kind of the average, right, of these two shapes, right? So what they're allowing us to do now, right, is essentially to automate that process, right? So, you know, you can have more flexibility and make changes in real time and see how they occur, right? So, you know, having that kind of ability in Grasshopper is really fantastic, right? So if we go back and we look at, after installing the plugin and we look at some of the components that are available to us, you can see, examples of, how to create basically tween curves, right? And in all different types of ways, like on surfaces, etc., right? You have similar functionality, right? Of blending and morphing mesh geometries, planes, right? Sub D, right? Surfaces, right? Essentially, a lot of those things are similar, right? Just different types of geometry. So in the past, I don't know how many people have kind of explored the menus inside Rhino much, but if you've gone to like your surface tab, you would have found like in this later section, right, things like blend surface or tween surface, etc., right? You also have those available to you, in your curve components, right? So if we quickly look and see what that does in our so let's say we have two curves here, right? If we went to our curve tab and used tween curves, you can see that it automatically kind of created an average curve, right, that exists between our two boundary curves. And of course, you can change the number, right? And it would automatically kind of create this kind of blending between one to the other one, right? And, again, that's functionality that a lot of architects, I should say, who are working in Rhino really appreciated, right? But in our release for Grasshopper, somehow there was no tools that were available to us to do more or less the same kind of thing, right? So you can see here that, starting with kind of that as a starting point, you can see that essentially what Pufferfish has done is that it's brought that kind of functionality back to Grasshopper, in more or less the same way, right? So we're able to achieve the same types of effects using all different types of geometry. So in a way, it's even gone way beyond what Rhino had offered us before, because it offered us the ability to do it with sub-D geometry as well as mesh geometry and all different sorts of geometry types, whereas we're limited to curves and surfaces when working in Rhino alone, right? So let's just see, for example, what something like this would look like. So if I were to take my single surface here, and I made a copy of it, let's say I made some modifications to it, right? So let's go to the point level, and I'm just going to change a few things about this geometry. Maybe turn it this way. I could do this forever, but just so that we can, see for sure what's happening. The only thing that I think that's important to keep in mind, though, is that this only works when the two boundary conditions have the same topology, right? What that means is that you really need to kind of build the two boundaries from the same geometry. So if you have a NURBS curve with 4 control points on one side, then you really want to have the same thing on the other side. Otherwise, the blend tool doesn't really give you a nice solution, right? Okay, so now I'm going to bring these two surfaces in. And again, you don't have to, if you wanted, these could be any surfaces in your definition, right? It's just that I don't have other geometry in here that's would really be suitable. And so just use what's available now. I don't know if it would be more interesting now if I were to go and like do some kind of transformation first. Do a twist or something. just see what happens. Okay, let's go with that. Okay. So I'm going to hide that first. Now we're working basically with these two surfaces. And in our example here, let's go ahead and use a, let's say, mesh, right? So let's say we're going to use our tween between mesh geometries. We have one mesh here, one surface here and another surface here, right? So the first thing you would do is you would convert any surfaces that you had into mesh geometry, right? So we can do that easily. This component. And, oh no, okay. So the standard, because these two are different shapes, the standard mesh strategy isn't going to work because it's going to create two completely different types of meshes, right? So instead, we're going to use a mesh surface, right, which you can find again in your utilities tab. And this will allow us to basically force the two surfaces to use the same resolution when converting to a mesh, right? So let's just, is that going to be scary? Let's see what happens. I don't think we need as much as 100, so let's just tone this down a little bit. And hopefully in this way, they now share the same topology, right? So you can see right away that the tween component was able to just directly find that kind of middle ground, right? And now this factor, which is essentially we can use a slider to control, will allow us to take a position, at what point in that transition zone, right, that we want that component to appear, right? So of course, what that means is that if we could create a series of values, right, for this factor in between the two, right, we could have an outcome that wasn't just a single surface, but was a large number of surfaces, right? So we could go to our sets, right, and we can come here and we can say, let's create a range of values, right? And that range of values sits between 0 and 1 by default. That's fine. And how many steps do we want? Well, let's say 100 is our maximum for now, and use that range as our factor instead. So you can see by doing that, now I'm able to, change how many iterations happen in between, right? One end and another, right? If I wanted there to be some kind of gradient, you can see it's all very regular now because we're using standard steps, right? So, 0 to 1 divided by 10, right? So each step is, whatever, 0.1. If I wanted to be able to create a kind of more interesting effect, a gradiated effect or something like that, well, then I need to change those values in such a way, right? And if you wanted to do something like that, you also have the option of using our graph mapper, right? So with the graph mapper, again, we can take our range graph type and choose a graph type that we want. to define the way that the behavior, that iteration, right? We're just going to use a Bezier. And you can see now that when I modify that, it's not an even progression anymore, right? These ones are smaller, and then it gets wider and wider and wider as we progress through, right? And, you can change it on both sides of the spectrum, right? From depending on the end or the beginning, right? Essentially, actually, what you're looking at is the slope of this curvature, right? The higher the curvature, right, the more exaggerated that gradient will be. So you'll have maybe several that are very, very close here, and then suddenly just kind of opens up and blanks out, right? And the more subtle, right, that change, then obviously the more subtle that transition becomes, right? So you can see that, simply by adding this functionality, but allowing us to use the existing tools within Grasshopper, actually we're able to create much more interesting effects here than we were able to do originally within Rhino itself, right? So I think the other component that Pufferfish, brought back was this idea of morphing, right? So morphing geometry in in Rhino was also part, one of the kind of stronger aspects of Rhino's modeling engine, right? And we lost that for a while again. And what we can do now is that we can actually use Pufferfish to allow us to implement, morphing strategies again, right? So if we take just the same basic geometry that we had, but instead of using a tween, we set it up to do like a box morphing. Let's say a twisted box with consecutive meshes. So we're going to go ahead and input our meshes into our box. And you can see when you've done that, it kind of divides the space up within, right? We can use our parameter tools to subdivide the same way. So you can see we've essentially used that setup that we had already established before. And we can change the interpolation type to chord or square root or linear. I'm going to use chord because I feel like it behaves most similarly to like a NURBS geometry loft, which I prefer. And so I've set up my kind of matrix of twisted boxes, right? And then the rest of it is very straightforward. So you need a geometry that you're going to replicate within that mesh. I'm going to tone this down a little bit because I think it'll actually be more clear. And you can generate that mesh however you want. Let's just say we create something. Let's create a sub-D box. And actually, I want to change this count to 3 and 3. 3. Okay. So I'm going to create a kind of sub-D box. And then let's do a simple bridge. From this face to this face. Oops. Okay. And then from this face to this face. okay. I think it's a bit dense at the moment. Let's start to modify a bit. So let's say that's our basic setup. Or actually, I like that better. Okay, so that's our component. We are modeled. And then let's go ahead and mesh that. I don't want too many details because we're going to be replicating it quite a lot, so that's fine. Maybe a little bit better than that. Oops. Mesh. I'm preferring to use mesh on this occasion because, again, mesh geometry is lighter, and you can see in this instance, if we're going to be morphing geometry into another geometry, and there's going to be so many, so many pieces, really, mesh geometry is probably your only reasonable choice unless you're running a supercomputer. So let's bring that mesh into my definition. Set one mesh, hide. Once that's set, I need to create a reference box. So let's go to surface, bounding box, content. Plane is kind of irrelevant. Okay, so we have our twisted boxes and we have our reference box. And so we just need to do our morph, right? So we can go and we can take that and we can do transform, geometry, reference box, target box. You can see now that geometry got morphed into or in between those two boundary surfaces, right? And if I now, let's just bake this out so we can see more clearly. So if we look at that now, you can see maybe more interestingly, right? That geometry has kind of been, pushed in to fit. And stretched and morphed. And we can still see the gradient effect, right? Tighter here towards the top, then opening up and becoming bigger on the bottom. And essentially that's that, right? So again, most of these plugins are, in a way, I think, trying to make up for the fact that a lot of things were kind of omitted from the original Grasshopper component set when it was developed for Rhino. But in a way, after adding that feature, you realize that in fact the opportunity there is way higher than it was within Rhino itself, right? Because of the added functionality, for instance, of being able to modify the speed at which that transition of those values occurred, right? Where in Rhino you really could only set a certain number of divisions at a certain distance, right? So a lot of fun can be had, I think, playing around in these plugins, doing kind of different things, right? So today's lecture is a little bit less formal than usual because, again, we are exploring kind of maybe less strictly architectural, and really looking at kind of add-on functionality rather than talking specifically about any kind of parametric concepts and whatnot. But I hopefully this serves as interesting and fun introduction to much wider world of kind of Grasshopper plugin components that you guys can try and explore on your own, right? And I said it over and over again. I think ultimately that's what this class is about, is to prepare you guys so that at a certain point you'll be able to come in here and click on any component, right? Have a look at it, get an understanding of what it does, right? And maybe try it out for yourself to see if these kind of effects are interesting to you in your design process, right? Because I think ultimately, it'll help you to create something more interesting and more unique. And the fact that there are so many different plugins available, 679, means that if you can develop a skill set with a few of them, I think the combination of that will already allow you guys to find your own kind of design language, right? And hopefully that'll make your work more interesting overall, right? Okay.